This section starts a series of shortcuts we have to take derivatives. You're going to love this by the time we're done because it will get rid of all limit notation for a good long time. So enjoy. First rule we have is what happens if we take the derivative of any constant. So for this one, just think of a quick graph of what a constant would look like. So let's say we're graphing something like that. That might be y equals 2 perhaps. And what would the slope of any tangent line be? The slope of any tangent line for this would be 0. So anytime you're graphing a constant, something like y equals 2 or y equals 10, the derivative is going to always be 0. So for example 1, if the function is 5, y equals 5, then f prime would have to equal 0. Rule number 1, done. Second rule is going to be very important. It is the power rule. This little paragraph right in here basically says that the book kind of splits it up into several chunks. We're just going to learn it all at once. Anytime you have x raised to a power, the general rule right in here just says bring into the front, bring that power down, and then the power that will replace it is 1 smaller than the original. And that's all we're going to be working on. It gets very, very simple as you get used to it, used to the notation. So, example 2. If our function is x to the 5th, what is f prime going to be? Okay, so f prime of x is going to be, we take the power, x to the 5th, we take the 5 and bring it down to the front. And then the new power is 1 less, so to the 4th power. So it's 5 times x to the 4th. The 4 is only applied to the x. Okay, example 3. We have function f equaling the cube root of x squared. So the first thing I might do for this is just rewrite the original function. The original function with powers would be x to the 2/3 power. Remember that the root is our denominator and then it's squared, so that becomes the numerator of our fraction. So as we go through this, f prime of x then would be, which we're really trying to find for this question, we bring the power down to the front, so we have a 2/3 out front times an x, and the new power for x is going to be 2/3 minus 1. 2/3 minus 1 is negative 1/3. Okay, so that would be our answer. 2/3 times x to negative 1/3. Only x is being raised to that power. And finally, for the power rule, we're looking at f of x equaling 1 divided by x to the 4th. Again, it can be very helpful to rewrite this, so I'm going to say that f of x really equals, remember, if we have stuff in the denominator, when we move it up to the numerator, the power becomes the opposite sign, so we're going to have x to the negative 4, and once we have that, f prime of x, we bring the power down to the front, so we have a negative 4 out front, times x, the new power is 1 less than the original, 1 less than negative 4 is negative 5. Okay, that is the power rule. At times can be a little confusing, but overall it's probably going to be the simplest one that we cover. Rule number 3 is the constant multiple rule. What happens if you have, c up here is our constant, if you have a number in front of the actual function, which would be u is the function. And basically what this rule is saying is just kind of ignore that constant for a little bit, just take it out to the front and take the derivative of the overall function, and then you can multiply them together. So some examples of that as well. If our function is 5 times x to the 7th and we want to find the derivative dy over dx, just think of it as 5 times the derivative of x to the 7th. So if we take a little bit more time to write it out than what you might, we'll just call it y prime for now. Our derivative is going to equal 5 times the derivative of x to the 7th. We just kind of covered that power rule, so we bring the 7 down. The new power will be 1 less, so the new power would be a 6. And then we're done. We just need to simplify it a little bit. So 5 times 7 is 35. The best way to write this answer would be 35 times x to the 6th power. Example 6, a little bit trickier. We have 4 divided by 5 times x cubed, all of that in the denominator. I think after a while you guys will get in the habit of rewriting the function, the original function, when it's a little bit more complicated. I'm going to do that right now and write it as, probably a couple ways that I could write it. I'm going to write it as 4/5, the fraction 4/5 times x to the negative 3. That would be equivalent. And so this rule is saying, just to start out by taking the derivative of function g, that is, oh boy, that's kind of gross. That is simply, just stop trying to be so fancy here. There we go. G prime of x is going to equal the constant 4/5 times, and then the derivative of x to the negative 3. Again, we're using the power rule, so I bring the negative 3 down to the front, times x, and then 1 less than the original, 1 less than negative 3 would be negative 4. And then it's just a matter of rewriting it so it's a little bit easier to understand. So first thing I'd probably do is just multiply the 4/5 and the negative 3 together, so I get negative 12 over 5. That negative symbol could go in front of the 12, it could go in front of the 5, it could go in front of the entire fraction, doesn't really matter. Then I have x to the negative 4th. And if I want to rewrite it so that our powers are all positive, I could rewrite that as negative 12 over 5 times x to the positive 4 power. That would also be an equivalent answer. So any of these are fine answers, to be honest with you, especially for multiple choice, though you're going to have to figure out how to narrow it down to the one correct one that they give you. And our last rule for this section of the video is what happens if you're adding and subtracting lots of things together. So you're taking the derivative of things that are being added or subtracted, and the rule just says take the derivative of the separate parts in order. Again, not an overly complicated one. So example 7 says if our function is y equals x cubed plus 4x squared minus 2x plus 7, we're going to find that derivative. Just take it one step at a time. So we would say that y equals derivative of x cubed using the power rule would be 3x squared. The derivative of 4x squared using the power rule would be, kind of do this a little bit more in my head now, I get 8x in the end. The derivative of, well, we're subtracting, so let's put a subtraction symbol there. Derivative of 2x will be 2, and the derivative of 7, a constant, is 0. And that would be what, not y, but what y prime equals. Example 8, basically the same thing, just going to be a little bit more complicated as far as what the original looks like. So the first thing I'll do here is just rewrite g of x. So I would say that g of x might equal, let's see, the first part there would end up being a 3. If I raise everything to the 4th power, negative 2 to the 4th is 16, be positive 16 now, and x to the 4th. I'll just rewrite the other stuff the same way for now. And then it might be a little bit easier to rewrite it once again and say that the first part is 3/16 times x to the negative 4. The next part might be negative 1/2 times x, and then just plus a 1/4. So that last part that I just wrote, this is what I'm going to use to take my derivative, because that's going to be a lot easier, but it's equivalent to the first step I wrote, which is equivalent to that. Sometimes taking the time to simplify will give you less grief in the end. Okay, so what is g prime of x going to equal? Using our power rule for the first part here, I'm going to bring the negative 4 down and multiply by 3/16. So we're going to kind of do that in one step here. 3/16 times the negative 4 that I bring down. You could simplify it first if you wanted to. We'll just write it all out and simplify later on. I'm going to say that's going to be negative 12 over 16 times x, and now 1 less than negative 4 would be a power of negative 5. The next part, if I go through the power rule, I'm just going to get a negative 1/2. Because I bring a 1 down as a power, that's not going to change the coefficient. And then I'd end up with x to the 0, which is just in the end 1. And then for the last part there, the 1/4, the derivative of a constant is 0. So this is one way to express the derivative. Probably the best and simplest way to express it in the end would be to say, if I were to simplify the 12/16, I get negative 3/4. Let me erase that a second. Okay, so negative 3 over 4, that's the fraction part, right, as x to the positive 5 power in the bottom, and then minus a half. So any of those would be fine answers, but you just want to be able to get to the last section if possible.